Good afternoon, friends. This is Jeremy Everett. This is a lecture for Discrete Structures, and this is our second lecture for the semester so far. I wanted to share with you a few notes. Before we get started on that, I'll go ahead and share my screen, make sure that we're all on the same page. So that's not what we needed. That's not what we needed. That's not what we needed. What I want to do is I want to begin by going to Canvas. So oh, guess it doesn't know me anymore. All right, so hopefully everybody's familiar with the SWASU website and able to get to Canvas. Once you're here to Canvas, we'll go to the Discrete Structures class. And there's a few things that I wanted to show you just to get started with. There we go. I'm gonna say, let's go look at the syllabus first. So here's our first week of assignments. And so we've got the introduction videos, and I'm hopeful that everybody's able to go in and get the introduction videos done. Specifically, what I'm looking for on that is just a way to put a face to some of the names. Let me look at the list of people right quick in the class. So Essa, I know you. Keith, I haven't worked with you as many times. Caden, I know fairly well. Isaiah, good to see you, my friend. Looks like you haven't got logged in yet, so when you see this, hello. The twins, Daughtry, always a pleasure to work with you. Unfortunately, I won't get to see you face to face. Allison, I will say, very hard charging student there. So hopefully we're able to have good discussions. Caleb also, no, that's Charles. I apologize. Charles's claim to fame, always a warm spot in my heart. He did the entire Computer Science 1 class from the command line. So not even autocomplete. Cody Jones, glad to have you here. Cody's been here for about a year. Opal, you got Student of the Year, but I don't actually know, haven't worked with you before. Reed often makes an appearance here. Great personality. Working with us on several projects, including the state high performance computing competition. Manu, good to have you back, my friend. Jonas, hopefully we get a chance to visit this semester. Ariana's got two distinctions. One is she was selected as a NASA intern, and a second distinction is she was able to also be selected for the Exceed Empower internship program through the National Science Foundation. Tanner, good to see you. Tristan, hopefully we'll get a chance to visit. Jessica, unfortunately, I know for Zoom calls, Jessica sometimes has to take them from her vehicle. So Braden, I saw you earlier today. Colby, I saw you earlier today. Trevin, I will admit, I don't actually think I know you very well. And so if you get a chance, make some welcome videos and say hello. So that's the introduction videos. Hopefully everybody gets a chance to say hello, share a few fun facts about themselves, and just kind of, make yourselves available to the rest of the team. Dream Job Project is something that's near and dear to my heart. Most of you have had a class with me before. Those of you that haven't, there's only a small number, but I'll keep this brief. Feel free to ask for clarification from your classmates. At the start of every semester, I ask my students to really nail down three things. The first thing is understand this class, understand what you need to do in order to be successful in it. Please understand that Discrete Structures is a sophomore level class, and that it is something that hopefully is able to help you advance your understanding of several topics. So understand that I'm here to help you be successful and work with you in whatever way I need to help you be successful. The second part of the Dream Job Project is figuring out what is it going to take for you to complete your degree. And so what that means is I want you to look at your transcript. If there's anything strange or unusual there, get that addressed. The second thing is I want you to take a look at your degree sheet and look at it and get familiar with it and try to make a course plan based off of your degree sheet and your transcript that comes up with basically a way the puzzle works out for you to complete your degree. The third part of the dream job project is for you to sit down and try to make an assessment of what are your goals and aspirations after you finish your education. And so if you know you're going to graduate school, well, what I would encourage you to do is contact graduate school and ask them what classes, what leveling classes do you need to complete in your undergraduate in order to be competitive and not have to take leveling classes. Um, but even after graduate school, unless you're going to be a faculty member, you're still going to have a career. And if you are going to be a faculty member, again, there are requirements and things that people are looking for and experiences. And so the goal of the dream job paper is to have you have everything lined up so that you're on your way to be competitive for your dream job. Now, what this is going to tie into is the gap analysis. And the gap analysis helps you identify, what does your resume look like today? And what does your dream job call for? And how can we identify what you need to address to get you from where you are to where you want to be? And so just like the course plan, the gap analysis is kind of identifying where are some things that you need to work on. Now, in February, next month, the start of next month, we're going to have Project One. And this is where you're going to write a detailed report, and the report is focused on making a plan. And that plan is what you're going to follow throughout the semester. Now, the project can be a number of things. The thing that I want to put your mind at ease, this is not an exercise where I'm looking for a way to weed you out of the class or give you a bad grade. This is not a separates the A's from the B's. This is an exercise to help you think critically about yourself as an individual, what it means to be a student, and what it means to be starting your own career as an adult. And this is why I have these conversations at the start of every class. I want to remind you, you need to be expanding your resume. In an ideal world, once a week, you stop and you pick the highlight of the week and you journal that highlight of the week down in your resume notes. And then you look at the month and you pick from the highlights of the week what's your one that you want to write about in your resume. And you take it from your resume notes and actually add it to your resume. And then at the end of the year or half a year, however frequently you want to do, you take those resume notes and you pare it back and you get the perfect resume for the jobs that you're applying for. And one of the students today I was working with pointed out, you also need to understand a resume going to, like if you're going to be an actor, that's going to be a certain style of resume versus if you're going to put in a resume for maybe a retail job or something like that. And there are two different styles of resumes, and you need to respect the audience that you're working with enough to identify what are they expecting and what are those personalities. So I would encourage you to go out into the field you're excited about, find some example resumes of people that have gotten hired, and try to emulate some of the things that you see. So anyway, that's the first week's assignment. The third thing is succeeding in an online class. Because this is an online class, I do hope you're able to go in and work through that. I've got a couple of emails that a couple of people have had problems with that. However, hopefully a majority of you are successful. I will get back to those emails as soon as I can later this week. Okay, so if you look at the schedule, we're also going to have some assignments due next week. And so I'm going to open that up so we can turn our attention there. All right, so in discrete structures, the primary focus is on the process to solve the problem. And I was explaining to one of my friends today, in discrete structures, you've got people that have good experience in mathematics and good experience in logic, and this stuff just clicks for them. And they will tell you that they're used to solving problems where you're given a question and you write the answer and you move on. And when you're very familiar with the material and you're just drilling it or reviewing it, you don't necessarily need a process. And a lot of math is drilling and trying to remember a process or a set of rules or something like that. And you're just kind of getting the repetition to get familiar with it. The reason why this class is different is because this class was designed for another group of people, which is a group of people that are less familiar with the mathematics. And what I mean by that is people that maybe don't have as strong of a background or haven't been exposed to this particular area. And there's a really good chance that you're not going to have exposure to this area because the book that we're using, which is from Ken Rosen, it covers a crazy amount of information, and every section is pretty much its own 3-hour class. And section 2.6 in this homework assignment on matrices is no exception. So the reason we have the same structure of questions for every homework assignment is because what I want you to focus on in this class is not so much did I get the right answer, because in the syllabus, I literally give you all of the answers. What I'm looking for, so that's part 4. That's so you can have the answer, so you have something to work through when you're looking for showing um, your work, showing your path from the question to your solution. And so I give you what the back of the book says. And for a lot of people that have taken a lot of other math classes, they would tell you, okay, yeah, that's just the answer. Like, what's 6 times 7? 42. You don't have to think about it for them. It's just a fact. This class is designed for you to think about problems. And that's why I ask that you take and look at something and try to, personalize it and express from your viewpoint what the question is really trying to address. I also ask you to, what other resources are you considering when you're trying to think through this problem? Third, I want you to come up with an assessment that says, all right, this is what I think the question's asking. This is where I need to be. How big of a gap is there between what my resources provide me and what I'm trying to do? The fourth thing is just put the pencil to the paper. And then the fifth thing is going to be to take a step back and say, do I honestly believe this or not? And this is a process that can be applied to grant writing, personnel issues, a lot of different things in life. And it's a general problem solving strategy. It's not simply for math. The reason why we use math as the example is because when I ask the question, what's 6 times 7? The answer is not, well, it depends. What do you mean by times? No, it's 42. And so the concept is there is a right answer and there's a way that you can justify it. Now, you can discuss that. You can say, this is why I disagree with what the back of the book says. You can have those conversations, and I encourage you to think about that. But this is a process that you can apply. We just use math as an example. And the reason why I do that is because in discrete structures, there's just so much information to cover. So anyway, without further ado, let's keep on rocking. So this is what the assignment looks like, and you're going to be creating a document. And so I'm just going to hit a reply, and I'm just going to put my name here. And then I'm going to do this. I'm going to see if I can get away with this. All right. And so we'll start here, and I'll do chapter 2, section 3. I do not have any ambition in life to ever become a better speller. If it happens, problem 5. If it happens, it's purely by chance. Let me look at something right quick. Actually, to make this easier, I'm going to do a Google Doc, and I'll just call this chapter 2. And so I'll go ahead and hit share, and I'm going to copy this link. Actually, change to anyone with the link and can view it. And I'm going to copy the link. And then I will come in here and just delete this and hit post. So now you can see my reply. Oops, need to edit this. See if I can edit it. It didn't recognize it as a hyperlink. That would be frustrating. All right, done editing. Now it recognizes it as a hyperlink, and now it'll open into this window. Okay, so now we can copy this again. Here we go. And so I'm going to format this to make it a little bit pretty. Chapter 2. And then I'll go in here and do this. Section 3. Actually, let's just do this. Promote this to this level. And now we'll do question 5. Promote this a little bit. And now we can come back in here and we can just highlight this part. Okay. All right. So now we need a sentence or summary of what the question is asking. Well, I got no idea, right? I haven't showed you anything so far that says what that is asking. So I can read it to the book, and that's not very helpful to you right now because you're out there in TV land and you don't have access to my book because we're not sitting in the office together. And so that would seriously suck. So that's why I did this. Here's a Google document. You come down here to where it says, let's see, course schedule. All right, so here's course schedule. Let's click on this and see what's there. Cool. All right, so now we've got something to work with, right? Here's question 5. So the nice thing about this, because I'll be honest, my brain's not going to think about this. I'm going to come in here and I'm going to grab it. And so we'll paste that in. And now we've got something we can work with. Okay, the question is, find the domain and range of these functions. Okay. I don't necessarily talk about domain and range of functions on a daily basis, but I know one describes the input and one describes the output. And that's what a function does, is it maps an input into an output. A list of references or resources to help answer the question. Well, because I said so, right? Every student always just wants to answer, well, because I said so. And that should be enough because I'm good at math and I've had much math classes. So you trust me now. Let's see, where did I put that? Here we go. So shared folders, files, and resources. I'm going to make an adjustment right quick. I apologize, friends. I think this is beneficial though. I'm just going to grab this and then I'm going to come up here to other resources. And let's do this. And now let's structure this in this document just a little bit better so it makes a little more sense. Because whether or not you like clean code, and I hope you do, clean code's probably not as important right now as the discrete structure stuff. And so we'll move that down here for now. All right, friends. So now you should have the link to the questions, and that's our questions right there. But you also have this handy dandy little thing. And so let's click on it and see what's in there. There's our class syllabus. That's handy. Here's some bunch of PowerPoint slides, and I do hope you enjoy those PowerPoint slides. And then we've got this. Let's see if it works. Hey, nope, that's not what I wanted to do, kids. So anyway, this can get really clunky. And so what I like to do is just do direct download, and it should bring up, and I'm going to put this on my hard drive. Actually, I'll just put it right here. And now I've got it open as a PDF, and I can change this. I can go here, and here's a little cheat. This is not very, there we go. So, and now Perfect. All right. So like I was saying, we're looking for the word range. So I'm going to do a control F and I'm going to do range. And there's 47 of them, and it doesn't actually show where these show up. That's still chapter 1, so that's not going to do. We'll just fast forward to chapter 2.3. Oh, it reset. And we can see, here we are. The range or image of F is the set of all images of elements A. So if F is a function from A to B, we say that F maps A to B. Okay, well, that's a definition, and it kind of talks about what a range is and what a domain is. And so I'm going to bop in here, and I'm going to say, we probably need to address this a little better. I'm going to say 2.33 definition. And I still don't feel like I really understand what they're talking about there. And so I'm going to grab this example. And the reason I do this is because I'm a bit of a simpleton and I don't necessarily understand things the first time I see it. So there we have it. We've got a definition, we've got an example, and it says domain range. And so it says the domain of G is the set, and the codomain is, and the range is a set because each grade except D is assigned to some student. What is the function that assigns? Let's go back and let's grab that first paragraph too. There we go. And I'll just put this right here. Okay, so let's see if we can read this. We assign an element, a set of particular element, a second set. For example, suppose that each student in a class is assigned a letter grade from A, B, C, D. And suppose those grades are, okay, we have an input of a name and an output of a grade. And so it says the domain is G, of G is the set of the names. Those are our inputs. And then the range or the output of G is the set A, B, C, D. Okay, so a brief description. The definition and the example help get us close. We just have a problem. Now, if you want to be fancy, and I really encourage you to be fancy, you can do stupid things. And so here's a stupid thing, right? I don't know that it'll let us do it here, but let's try it anyway, because I love stupid things. And, oh, yep, here we go. And here's another stupid thing. And the concept that I want you to take away is, hopefully this just makes it so much cooler. I'm going to make this part in red. Nah, red doesn't work. Make it blue. Blue doesn't work. This should not be this hard. There we go. So this is just kind of highlighting the part that we're answering. All right. Now it says your work. Okay. First thing I'm going to do highlight it. And now I think the highlighting falls off. Nope, it didn't. So there's actually several parts on this question. Let's take a look at that right quick. There's A, B, C, D. And so let's do A first. I said I want the highlighting off. Did we fix it? Okay, A. And A says the function that assigns each bit string the number of ones, the function that assigns to each bit string. So let's give a bit string right quick. I'm going to do 1100 1100. You're still doing dumb things. We'll just tell it to do this color. Cool. So this is our bit string. All right. And now output equals, what's the function say? It says each bit string, the number of ones in the string minus the number of zeros in the string. So this is going to be, we're going to have, let's see, 1, 2, 3, 4 ones. So we're going to have 4 ones and 1, 2, 3, 4 zeros. 4 zeros. So 4 minus 4 equals 0. Cool. So our domain is, based off of the example, that's our input, any string, and our range is an integer. Okay. All right. I'm so nervous right now. I have no idea if that's right. What do we do? How do we solve this? If only there was a way. Oh, wait, there is. So one of the things that I came in and I did was I made this little Google Doc. And here's the answers to the odds. Now, here's the answers to the evens. So we need to go back. Here's the answers to the odds. And I'm going to go ahead and do a direct download, and hopefully it offers me, yeah, we'll just put those in the same folder. And so now we come down here. Blah, 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 blah. Section 1.4, we're looking for 2.3. Actually, let's do it this way. Yeah, there we go. Now we're into chapter 2, Venn diagrams, always a good time. And 2.3, and now we're looking for 2.3, number 5. So I'm going to do this, and I'm just going to grab 5, and it goes all the way down here. So we'll just grab that. We'll bop in here, and I'm gonna come down in here. Where do I, you know what? I'm just going to put this right at the top. That's small. My eyes are old and not good, so I'll readjust. Okay, so it says the domain is the set of bit strings. So any string, we'll say set of bit strings. So I can see how theirs is more specific than mine. All right, now the range output is the range of the set of integers. So they're asking us to define a set, and that's pretty cool. All right, so we've got A knocked out. Now let's go take a look at B. And it says, B says, the function that assigns to each bit string, all right, so this is nice. We know that we're still going to have this. Yeah, I'm not good at technology. There we go. So we know our domain already, and now we're going to have a range. And let's read the question again, part B. It says the function that assigns to each bit string twice the number of zeros in that string. Okay, now this is interesting. Can we have 0 zeros? Yes. Can we have less than 0 zeros? No, because when you're counting things, you don't ever have any case to count negative. And so it's going to be the set. Let's see if we can write this one right. The range. The set of 0 and they say non-negative. I cheated. I looked. Okay, so for B, the domain is a set of strings, which is the same thing we had, and then the range is a set of non-negative integers. Cool. So I feel like we're getting a little bit better at this now. Okay, part B, part C. Now let's go up and let's take a look. Part C, it says, all right, this is the function that assigns the number of bits left over when a bit string is split into 2 bytes, which are blocks of 8 bits. Okay, now we're actually getting specific, and it's not just a bit string. It's when a bit string is split into 2 bytes, which are blocks of 8 bits. So each byte has 8 bits. It's the function that assigns the number of bits left over when a bit string is split into 8 bytes. And this is one of those where it's late in the day, my brain's not functioning very well. I would tell you that I think the input is still going to be all bit strings, but I'm going to say it can be any length. But I think this is going to be clockwork arithmetic. So it's going to be something like, what I mean by that, okay, what time is it? Well, it's time for lunch, or everybody outside, everybody outside. No, what I'm saying is the way a clock works is, it's 1 o'clock, it's 2 o'clock, blah, blah, blah. It's 11 o'clock, it's 12 o'clock. It's 13 o'clock. No, okay, maybe. But a better example would be, today it's 11 p.m., now it's 12 p.m., now it's 1 a.m., and there's a clock, and the clock just keeps going around in the same numbers. So if we've got a bit that is 8, if we've got a bit string that's 8 bits long, and we break it up into 8-bit pieces, what's our remainder? 0. If it's 9, it's 1. If it's 10, it's 2. If it's 11, it's 3, 4, 5, 6, and 7. But once it gets to 16, and we break it up into 8 bits, so 15 would have had a remainder 7. So 15 minus 8 is 7. But if we do 16, 16 minus 8 is also 8. 8 minus 8 is 0. And so our remainder is 0. And so I'm going to say our input is all possible bits, but the output is an integer of the set 0, 1, 2, 3, 4, 5, 6, 7. And so let's take a look. I'm going to say domain, any bit string, and range. And it says non-negative integers not exceeding 7. So I'll type it the same way. 0, 1, 2, 3, 4, 5, 6, or 7. Okay, now let's go for part D. And you can read the example right there on the screen, and you can see, there it is. All right, part D. Before I can read that, I'm going to just scroll up. And it says, this is the function that assigns to each, gee whiz. Okay, to each positive integer. Okay, so when it says, this is Sesame Street, right? Part C, the function that assigns the number of bits Part B, the function that assigns to each bit string. Part A, the function that assigns to each bit string. So pattern recognition, the function that assigns to each positive integer. So the domain is positive integers. So, and then the range is going to be, and what does it say? The largest perfect square not exceeding this integer. So I'm going to say the range is going to be, and I'll hide this just a little bit to make it more fun for me. The set of positive integers, and it's going to be the set of positive perfect squares. Okay, let's scroll up and let's look at what the answer is. And it says the domain is the set of positive integers. Yay, we got that right. So the set of positive integers, and the range. It says for the range, the range is the set of squares of positive integers. And it actually gives examples. And so let's all right. So 1 squared equals 1, 2 squared equals 2, 3 squared equals 3, dot, dot, dot. 3 squared equals, how about 9 and 4? You know, if we were in class together right now and you didn't heckle me for that, I would give you a hard time because hopefully somebody in the class would have picked up on, hey, the old man is slipping. Okay, so the concept we have now is we've got a nice little pattern. We've got some examples. We've got a definition, and we were able to go through that and work through the process, and then come up with something that matched. And so I'm gonna write it this way. Um, Okay, so expectation management time at this point. It is almost 5 o'clock, and so far we've gotten one problem done, and we didn't make very good progress on it. So here's what we're going to do. These should be taking less than an hour. These should not be taking some really, really, really long time. Um, let's go see if we can work through problem 6 a little bit faster where I'm not talking as much and just kind of trying to get more work done. So this is 2.3, number 6. This one. There we go. All right. So the first thing I need is this. I'm just going to grab it right quick. And I'm going to look down and verify. This one is also find the domain and the range of these functions. And it's part E, assigns a bit string to the longest string of ones in a string. Yes. So we've got that here in this book, and I just verified that, so I feel happy. Let's paste that in. All right. I'm going to make this a little bit smaller so it's easier for me to manage around. Not that small. Okay. And so now we will paste in our template. And I don't know that you always have to paste in the template, but I like pasting in the template, and I like to paint the template pink because I just like that. I like colors and I like fun stuff like that. And I'm going to use the same template pattern down here. So I'll go ahead and do that. And now, okay, we're going to change it to green. So and for this, I'm going to say, problem 5. And I feel like this one is a case where they really are the same problem. If you read this, it's find the domain and the range of these functions. And in this one, it's find the domain and the range of these functions. It just doesn't have the note. Okay, so now, what's this one? A brief description of the general assumptions. All right, I'll punch this. So in the earlier chapters, hopefully you don't have to take too many steps of faith. In the later chapters, these assumptions, some of them, you might be able to just make an assumption that really simplifies a question. Okay, so our work showing what we got. All right, so I'm going to say A, and the function that assigns, so our domain is each pair of positive integers. So I think from last time that you're going to use something like that. And so let me see if I can get away with this. I can. And then range is the set of positive integers. Okay, so that one I feel a little wonky on, and I've got some doubts. So let's go see if we can find that answer. Answer to odd? No. What I want this time is see if this is it. Ah, there it is. Okay, so we'll just grab this silliness right here. And I'm going to tell you already that smells funny to me. Okay. So I'm just going to drop that right here. And let's see if we can. Whoa, that's actually ridiculously rink-dink small. Do you let me do that? You don't let me do that. Okay. The domain is pairs of positive integers, and the range is positive integers. Okay, so you can basically put in any pair of integers. All right, so part B, it says the function that assigns each positive integer its largest decimal digit. So this case in B, let's get this going. It's going to be domain is all positive ints. Range is because if it's a telephone number like 911, largest integer in that is going to be a 9. Okay. And since, okay, so they're saying 1 through 9. That does make sense. Range is from 1 to 9. So I'll just update that. Okay, question C. we'll talk about this. A bit string. So again, it's all of the bit strings, and the domain is going to be all integers. So is that right for C? So it is ones minus zero. So it can be any positive number or any negative number. See if this agrees. All bit strings, 1 minus zeros can be, yay, that's kind of what I had said. All right, that doesn't fit on a page, so let's fix that. Okay, D. Function assigns each positive integer to the largest integer not exceeding the square root. All right, I'm about out of time for today's discussion. What I wanted to share with you is that there are all of these resources at your disposal in the syllabus. And hopefully you see where these documents are. And if you have a hard time finding these documents, we're going to continue to refine where the documents are kept and how the documents are used, because I want you to be successful. And I don't want you to be like, oh, but I couldn't find the book. Oh, I couldn't find the answers in the back of the book. Oh, I didn't have the answers to the even problems numbers. Like, I want to take all of that business away so you can focus on what's the process to solve a problem. And you're not like scratching your heads. You're not like fumbling in the dark. Because right now, I feel like all of my students in my discrete structures class feel quite alone, mainly because I feel quite alone while I'm recording these lectures, talking to myself, while there's like one or two other faculty here on the floor with me. And there's nobody in my office to talk about, nobody on the Zoom call with me. So hopefully this was beneficial. Hopefully you got to see where the tools are to solve these problems. You saw where the odd answers are, odd questions are, where the even answers are. You saw where the kept questions are kept, and you saw where the book is kept. So hopefully together with all of that, you're able to be successful and find what you need. All right, friends, I'm going to go ahead and wrap that up. One of the things I want to put in here is if you go through the syllabus, there is also the link to video recordings, and this should take you to the folder where you can see the videos that we have. So if we go into discrete structures, you can see this is my lecture from the first day. And then if you're watching this video, you found the lecture from the second day. All right, friends, with that, I do thank you all for your time. I appreciate the opportunity to visit with you. If you get a chance to swing by office hours, or I'm going to be trying to record these videos at 4 o'clock, Monday, Wednesday, and Friday, getting done before 5. If you have any questions, let me know. One last thing, and this is a doozy of a last thing, and I'm sorry I didn't mention it sooner. The tests. I had one student drop because of the test, and they're like, your programming is going to light me on fire. Yes, I am well known for giving tests that light people on fire. And hopefully you can feel the sarcasm in my voice. What the plan is the tests are all programming exercises. And so I actually took the day off from class that day. And my plan is I'm going to sit in Java and I'm going to try to write the programming exercise to solve the same problem that you're trying to solve for the test. Because I understand that just because I show you how to solve the problem doesn't necessarily mean that I got the code to work on your computer. And so there's a lot of things that have to happen, even if you know how to solve the problem. But if you don't know how to solve the problem, and you don't know how to program, and you don't know how to do any of this, at least you've got a place to start. And all the other issues we can work through together. And I don't want anybody to feel like they're in over their heads. We're going to get through this together. This is a lot of fun. We're going to talk about a lot of stuff. And, I've got to admit, I teach computer science, so I don't necessarily get to talk about the domain and the range of things very often in my classroom activities. When I get out to my research activities, the number of things that I come across are just phenomenal. And it's a lot of fun when those things show up here in our discrete structures class. And the reason of this class is I'm giving you a framework of how to solve problems. And I'm also showing you how to think about some of these problems in different ways. So with that, I'm going to stop the recording. I thank you all for your time. I hope you have a wonderful day. And if you get a chance, please send me some feedback and let me know, is the class working? Do I need to hang other information out there? What can I do to help? Thanks and take care. Bye.